good answer.
He was ordering from McDonald's, and he was just laughing at the person, like for no reason. Like, the video during the show.
Okay. Why are you in your phone? Your work should be out. We're just continuing the work we did last day. When you were done that, come and see me and show me. You can start on the actual worksheet, which is there we go. What the?
Probably really shy.
Oh. Dummy. Well, I just thought X was the X value. Okay, am I wrong?
Oh, carry on. Hmm?
Oh, you weren't here last time, were you?
Go back to the Google Classroom. Yeah, there's a gizmo that goes with it.
They could just be all on the same X course.
No, that's the worksheet. Go back to it.
Yeah, see?
No,
If you go to description.
Yeah. Yeah,
Gizmo login.
isn't it just the same as what the
Yep.
numbers
And there was a class code again.
It's like one equals a nine. Yeah, how do you? Okay.
So, if you know the rules, then you can do the JV. Nothing marker.
No. I think I dropped all my markers in my room.
I don't have a list. Or give me like a piece of paper. I don't have these straps.
No? And you sent it to the email. I forgot what it means. It's meter squared divided by
No, you make a.
What are you doing?
No, just
Yeah.
meter
Notes. You don't need Google. That'll take you more time. Just get your notes up instead.
Does like that's not that good of a picture.
Yeah.
Is there a mouse like he looks a bit fat.
That's not a huge difference. I mean, let's say you had a picture like that on a test, and they're at two different heights, and I'm expecting you to at least mention the two different heights. And if you also mentioned, well, their mass could be different, and this is why it would make a difference. There's nothing wrong with it. Yeah. Have you seen the 100 ways to solve the barometer problem? Don't know if I said the title right, but
Oh, just the 1% of energy.
You guys like the balls
Pardon?
It's
It's
such
like,
a
what work equals potential, assuming that it's not already consuming that. Because it say walls here, I use this much work to get it up, and there should still be this much energy to drop.
Yeah. Work isn't potential energy,
Plus already.
but they're measured both in joules. It's that you can use work to transform it from an area where it doesn't have potential energy to an area that it does.
That's not F, that's E.
Okay.
And the reason they're also not the same is that we are assuming that nothing is lost. But of course,
Also because it's
Yeah.
like, I can take the ball, I can move it here. Now even though I moved it this far,
Yeah.
there's still more potential because I went from here to here.
yeah, yeah.
Yeah, you did, because the first shovel, hit me in the head, and then my lip was bleeding, so I couldn't do it.
No, like you're not allowed to play when you're on the
Yeah, like you can't be like actively doing it. So like I just, no, I just stopped it from bleeding, so they had to send me out and apply. While they did.
So if zero point one equal to and
Was that the game?
so we don't know the math.
Was that against?
So
No, that was against Claremont. That was when the Jackson got played.
We're trying to find
Bro,
the maps.
they call me the band at acting BPP.
Yeah.
Like, how do you mess up that bad?
Wait, isn't G gravity? Oh wait, it's like no, that's not what I'm Get your calculator.
Who? Okay.
Okay, so like, oh, okay, so this morning, right? I was like, I'll just like,
No, it isn't. It isn't paper. Oh, the one has the most potential energy. What are you talking about? Sure, it's not that hard. Just drop it. Drop the place and put it in the other.
Five.
no, it's just point two.
Now times it by 9.
Times 2 1, this would be 0.981.
Times it by 9. Okay, so that's the that's what we can do.
So we could round up to 1, which is what I was saying.
Does it?
Oh, just round it up.
I'll just put 0 in that.
Okay, but the clips are gonna be different.
Okay. You do this one, and then I'll do the final one.
Okay, which one's that with the clips?
This is the second one.
Mr. Newfall,
Yep.
when are we gonna upgrade back to the
Wait.
acid?
How does dummy go?
The one you just handed in?
The weight in newtons is
Future?
the same thing as.
I don't have a date in my mind. I'll be giving it back.
That guy times.
What about our tests?
Normally it
Before you write your exam, because you'll have to study from them. Hold it. You haven't seen them on zip grades? I'll need to go and double check that they're in zip grades so you can at least see your mark.
Do you have those like things that are using passwords?
Pardon?
I don't think I have like using passwords.
Okay, I can get those hopefully for next day. Print out a new set. But I don't know if it's in there. I may have to go back in and tell it to publish them.
Okay, do we just not have to do two?
No, we just do that one. So how do you do, suppose if the proposed partnership, you would do initial show your work. Do I actually have to show my work?
You, oh, well, if it's at one, then you just times it by 5.
Do I just do
No, you go, you show your thinking. No, 'cause that's the weight. Yeah, so you're solving for the challenge. Okay, we have our notes.
it's E equals mg, it's really that issue.
Okay, so what's that?
N is 1. See, what, no, N is mass, it's 0 point. Wait, no, but mass needs to be in kilograms, so you do the weight in newtons divided by
This
mass.
Is this like, can this be like the same?
The ball has a
0.9.
joules, the gravitational potential energy, and the weight. Show me what you do. I'll be right over
I
there.
like did the mass first, like this, and then I just multiply the mass by like 9 times. And they give, and it's like the same answer.
9.1. Hold it. And then, okay, so you did that for the weight, and how did you do for the potential energy?
Oh, I just got it from the table.
What did you use?
Is it on the ground, like at 0?
No, like at 1 meter.
That's the,
Oh, well then that makes sense.
So mass, yeah, that's the mass of the first.
So it's gonna be the same.
Well, you're multiplied by m times g, right?
Mm-hmm.
What's height?
1.
And what's anything times 1? Yeah,
Okay,
that makes sense, yeah.
Okay.
Yeah.
Okay.
So, it isn't unless it's at 1. So that's just a specific case.
so what was the equation? Show your work. Here, show your work. No, what's the mass? Or like, what was your equation? Okay, go back to the calculator. times. This is not. You can see the. No way these 200. This is the movie. This is the people. What? Why do you look at how much cheaper? So now, it's such humongous.
Question. This will fill.
Mm-hmm.
For question 5, where you're calculating the kinetic energy of a ball drops in 2 meters, how are you supposed to do that? Because the ball isn't moving 9 points. Like, it's
Bring me what you're talking about.
Why do you have a glitter pen? I have 100 of them. I have some.
For this one here, how do I calculate kinetic energy? Because it's off a 2 meter shelf, so it's not going to be going to speed of gravity yet.
As object of potential doing it, how much kinetic energy do you think it will have just before it hit the floor?
Yeah.
It dropped from a 2 meter shelf. So yeah,
Because then it's-
at the 2 meters it doesn't. But
But
just before it hits
where
the
kinetic
floor.
energy equals velocity, but to calculate the velocity of that, it's not going to be going the speed of gravity yet because it hasn't equaled the 9.81 meters, right? To be going
Oh.
right.
Oh, I see what you're doing.
Because
No.
it's not going the speed
I'm-
yet.
I'm
Because
gonna-
it's not going to instantly go the speed.
I will relate
How
that
do I-
another way. I once took my van out into the highway.
Yeah.
And after 2 minutes, I stopped by the police officer who said I was going 200 kilometers an hour. And I said, "Your officer, you're wrong, because it hasn't been an hour yet.
Yeah, but it's not going to.
It will be going a speed.
Yeah.
Yeah.
It's not going to be going 9.81 meters per second.
It doesn't have to go down, but it has to
Then
go.
how do I
What's the
calculate
formula for kinetic energy?
Kinetic energy is half of mass times velocity.
Squared, yeah.
Yes, okay.
Does the V have to be any particular value?
I told him I was
No.
You don't
Any
have to.
any velocity that it is.
Yeah, I know,
so-
but how do you calculate the velocity that this will be going when I drop it?
You have to share one, so it's like, no. Just go to him and say,
That's because I can't figure out how to calculate the velocity.
The secret here, well, you could, but you can't, because I haven't told you how to do that. But
Yeah,
there's another way to do the
given.
problem.
Another way to,
Yeah.
well, I mean, do you just go backwards because you know how much potential energy it'll have?
There you
So
go.
then you just
Yeah.
put in the amount of
Yeah.
potential energy, it'll equal
There,
the
because
kinetic.
that has to be what it is. Because at the bottom, how much potential energy will it have?
Well, it should have, but it also has speed though.
Yes.
And speed is added to, so it's still gonna have the same amount of potential energy.
No.
Because if I drop it here, if there's no wind resistance,
Yeah.
it's gonna pick up speed,
Yeah.
right? Now the ball
How much
has
potential
speed.
energy does it have here?
Here it'll have, say, 2,
Right. And just before it hits the ground, how much does it have?
It's still gonna have 2
No.
because now it has
No.
speed.
No. How do you measure potential energy?
It's height times gravity times mass.
Right. Mass and gravity won't change, but the height will. Just before it hits the ground, what's the height?
0.
So what's the
Basically.
potential energy?
Well, 0, but that doesn't
No.
include
You can't
speed
say
then.
whelp zero. It's zero.
Yeah, but then what about speed?
Speed doesn't matter for potential. So
doesn't?
when it's here
Yeah.
and it has all potential energy, what does it have zero of?
Speed.
kinetic energy.
Or okay, yeah.
And at the bottom, it's all kinetic and zero potential. So it converts.
So if something has speed, that doesn't count as potential energy.
Figure out the task here.
No. Okay.
It's kinetic is energy of movement.
Okay.
Yeah.
Okay. So a car that's moving like 100 kilometers an hour, it doesn't have any potential energy.
No,
or
it's
just
kinetic.
all
It is
kinetic?
actively
Okay.
got energy.
Okay.
Yeah.
I don't really understand this question.
What are the masses in kilograms of the units writing their masses?
But you don't know the mass.
Yeah, you do.
But you don't know
Meters. Oh, well then you can calculate it. Well, you know their potential energy, and you know their height, and you have a formula, and you know G.
So you calculate the mass, and then, because you're supposed to know kilograms. And that's the use.
Wait, how do you check the mass?
Kilograms is mass.
Really?
Yeah,
Oh.
yeah. So energy potential equals mgh. You have G, you have H. You have the energy in joules. You could just divide the energy in joules by those other two and you'll have the mass.
So you divide the potential energies by the meters?
Here, I'll show it to you on the board in terms of the algebra. If you have, oops, potential is mgh, right? And you have that, because it's on your table. You have that, How would you get m by itself?
You just divide it.
You just divide it, yeah. So you just go EP divided by GH. And you'll get m.
So you do, it's the potential energy, and then you just divide that.
Divided by 9.81, or 9.8 I think they use, and then whatever height it happens to be where you've got that number.
Okay.
Yeah?
So it's the potential energy, and you divide that by 9.8.
Yep.
And that's going to equal.
And divide by the height.
And divide by height. Okay.
Yeah. Yeah. You're welcome.
Times 5. Yes. Yeah, that's what I've been doing all along. Now you're trying to get yeah, but you have the hard question. I had to wait. How did you
Well,
get
there-
that wrong?
Just doing drug you all for a minute.
What's wrong? What?
Bertie asked a great question. On one of them, there's two people on different heights of diving boards, and it's like, well, obviously the height kind of makes a difference, but I think one person's a little bigger than the other. Should I mention mass? I'm like, you could. That wasn't the intended thing, but if you did, it's not wrong. But height is really obvious. You should probably also mention that. This relates back to a very famous meme that went around in physics teachers in like the 70s, and has a real, and then everyone clapped and his name was Einstein kind of feel to it. But a student is writing a paper. He's asked to measure the height of a building using a barometer. And if you're doing that, you know that you can, measure the pressure of the atmosphere at the bottom of the building. You can measure the pressure of the atmosphere with a barometer at the top of the building and use a calculation to come up with the height. Well, the student said, I'm going to take the barometer, I'm going to tie it to a string, lower it to the ground, and then just measure the string. And the physics teacher was like, that's technically correct, but that's not what I wanted, so you're wrong. And then it will go on, and he says, you have to give me one that demonstrates your knowledge of physics. Well, you can take the barometer, put it against the, if it has a staircase on the outside, and just walk up the staircase and measure how many barometers it takes to go up, and then measure the barometer and multiply. Or we could take the barometer to the top of the building and just drop it, and time how long it takes to hit the ground, and do some physics calculations, and use that to figure out the height of the building. Or if the sun is shining, you can measure the shadow of the barometer and compare that, the length, to the shadow of the building, and use the ratio to work out the height of the building. You could also, really be scientific, tie a string to the barometer, swing it like a pendulum at ground level and then on the roof, and then you can work out the difference in gravity. That would take some fairly highly sensitive instruments. And if you want to be boring about it, you could do air pressure, or you could just go find the janitor and say, can you tell me the height of the building if I give you this nice brand new barometer? Any physics questions or any questions in chemistry or anything that you get is probably going to have more than one solution. You're never wrong for providing another solution. Usually you're doing something that you're intended to show your knowledge of, so barometric pressure. And if you don't put that there, I have to find it somewhere else. So if you know that, it's not clever to give something else. But if you don't know that, it is very clever to find a different way to do the solution. So you're never wrong for putting something else in there that actually works. But try and do it as an addition if you can. I will do that. That makes sense, yeah. Well, 0.098, or no. Are you sure? Yeah, because it'd be 0.1. That makes sense. That's for the mass, right? Yeah, that makes sense. Well, so your numbers, you took this. Where's your height? Is it 1 meter that it's at? Oh, then divided by 1, yeah, that makes it. Because 98 divided by 98. Yeah.
Oh wait, here, because we learned all this, right? So the GP is just kilograms meters squared over seconds squared.
Work is,
Zero. What?
weight is newtons, work is joules. Double check when you put all your units in. If you get a kilogram meter squared per second squared, it's joules. If you get a kilogram meter per second squared, it's newtons.
For this one, if we don't know the
I'm sorry, what did he say?
1 half mv squared, but you actually don't need
Meters
it.
squared over seconds squared.
Meters over second square.
So I think the question is easier than you're thinking. You don't need that formula.
Help me?
Not at all. There is, the only formulas you need are the ones in class. Pardon? You wouldn't need balls.
I'm doing life sciences.
Zoe.
Okay, so you did this question.
and did you say that you do 34 divided by 2?
I know.
And then that's 17.
One
But it's like
times the meters over seconds.
1.47?
What do you want to know?
That's not a big
But then you put it 1.47.
meters per second?
But then you have to do square root of that, right?
Yep.
How do we know that? Actually, no, I have
Square root of 1.47 is 1.2.
Yeah, we're in the same place.
Okay.
No, that all is easy. You've got units and everything. In most places. You've got your formulas there. The only thing I'd quibble about is just put your units in things.
Okay.
Just to make sure we can see that. That's going to be more important. You're taking physics next year, you said?
Yeah.
Yeah, your teacher's definitely going to want to see all your units.
Kinetic energy, like, say I have a ball, I drop it from like 18 meters, right?
Yep.
I drop it 9 meters, or say 9.8 meters, or whatever, right? Then I take it, the potential energy of that should just be equal to 9.8 meters left, right? But then you've already had that much left, so but isn't it gonna increase the speed as you go, right?
I'm not entirely sure your question.
So I'd say I drop
Can I
it.
rephrase? Are you saying that as you go down, your speed is increasing?
Yeah,
Yes.
speed should increase.
Yeah, so as you go down, your kinetic energy is
It's gonna increase.
increased.
So, but then wouldn't kinetic energy equal kinetic energy, or potential energy plus kinetic energy equals final kinetic energy? Not just.
You said
Oh,
wouldn't
you go to
kinetic
table.
energy, wouldn't
What
A
is-
equal B plus A?
No, what I mean is like, cause say the ball's already moving, right?
Yeah.
Then you look at potential energy, right? You measure potential energy, and then the kinetic energy at the end is not gonna just equal potential energy.
Yes,
Right.
it is. It cannot equal more than that.
But if the ball's already moving, right, now it already has kinetic energy.
Did you throw the ball?
Is equal to mass times.
Say you drop it off a really high building.
Okay.
Sometimes I say right? But you can look to see the potential energy happening down, you have
Yeah.
kinetic and potential, right?
Yeah.
But then once it be that potential energy is not gonna be equal to kinetic energy, it's gonna be
starts at 0. We have potential energy. Oh, hold. Oh, what am I doing? I have things. I have graphical things. Where are my graphical things?
Oh, meters.
Do you want us to round it to 1 decimal place?
Take the number with the fewest digits
Okay.
and then make your number to that many digits. It's like decimal place, but you just count the number that comes before the decimal as well.
Yeah, to like round it up.
Yeah, yeah. Be right there. I'm just answering one for let's see if I think that one works because it gives it as you do it. Potential, no, where's, what? Did I not? Oh, there it is. Skateboard simulator. Playground. So, because although this is not a ball,
Yeah.
I think, does it give us numbers? No, it doesn't. Oh, graphs. There we go. Energy graph. Kinetic, potential, forget about thermal. Position over time. Perfect. So, as we're doing this, potential is blue. So whenever it starts up here, blue is at the maximum, and green is at the minimum. And then when it's at the bottom, they entirely reverse. So there's no extra of either. If it's at the very top, it has maximum potential. If it's at the very bottom, it has maximum
But if you're like halfway through, then
So when you're halfway through, you can have an even amount of both.
okay, so then you would add both of them to equal.
You get the total energy. That's called, oh, okay. We're doing that, we do that later. That's called like total mechanical energy. That's your potential plus your kinetic.
Yeah.
But when you're at the top, all of that is your potential. And when you're at the bottom, all of that is your kinetic. But if you're halfway, if you add them both together, you'll know the amount that you could convert into the one or the other.
Oh, okay.
Oh,
That's,
we could even go in slow-mo.
Because that's sort of what I was asking there, is because that way if it already has speed, that would be that it has kinetic energy. Which then has it so that it can be converted to potential.
Yeah, yeah. So it's halfway down, it still has potential that's converted.
Okay.
Yeah.
Yeah, I see.
I should link, I just found this isn't linked on our classroom. I'll put it on there so people can also do it. We can also give it a grid and a reference height. So there's our 0. And we can change the position. It's currently at height.
You can use top middle.
I don't know if you want to type.
Yeah.
Oh, you get a new one. Yeah. Yes, yes. When you are done, that particular one, there is a worksheet for homework. Is that the very last one? That's true. You can't calculate it that way. Exactly. Pardon? No.
This would be one of those moments. Okay. No, I want you to watch this. In fact, come up here.
What's Ivy, for example?
Let's can I move this?
What? Why am I muted? I'm gonna bend.
Now, the blue. Come on up. What are you doing? And I'll make this go normal speed. There we go. No, slow speed. Okay. The blue is your potential energy. When is it at its highest? At the beginning. Or at the other end, right? When is the kinetic energy at its highest? In the middle, right down when it's at 0. If you had no way of calculating the kinetic energy here, like if the graph of the green wasn't there, how could you calculate the blue?
6 a.m. to 7 a.m.
Like, let's say you couldn't calculate the green one. Like there, all you had is the blue graph. Let's take that off. Connect. So you don't have that. Can you still tell where the kinetic energy is highest? Where? Where it's lowest. Now, what would the kinetic energy be there?
Oh my gosh.
Like, how much is the kinetic energy when the potential energy is there? Yes, you do. You can get it from this graph. I'll put that back on. Pardon? Why do you say 5? 5 what? Oh, it's at position 5. It's right in the middle there. But you want to give energy, right? What did you say? Why did you say about 2000? Yeah. And what is that top of the green? What is that the same as? Right there, where is that the same? When you look across, where is it the same?
Of the beginning of
The beginning of the blue. So maximum potential energy is the same as the maximum kinetic energy when it hits the bottom. They have to be the same. The energy can't be created nor destroyed, so it had to come from somewhere. So at the bottom, you have no potential energy, but it's all been turned into kinetic. And for this one, we haven't added any friction. Yeah, there's no friction, so we're not worried about thermal. And there you have the kinetic energy when it hits the bottom. Yeah. Do you know how they calculate the calories in food? They take the food and they burn it until it's ash, and they calculate how much heat can eat.
Oh, I didn't know.
Your body takes apart food and burns it. It's the same energy, so it doesn't matter how you got it. That's the maximum amount of energy.
I can't think.
No, you gotta calculate it. So, use this formula. How would you calculate mass? Just in formula form. Use this. What would you want mass by itself? What would you do?
I woke up right here yesterday to make some french fries and you were there.
Yep.
Did you buy some?
Yes.
After you got upsell. Carter's
You don't have to.
I don't have to. So it was,
You always have mass.
when he dumped oil into
Because now you're physics.
it cost $2,000.
Yeah, but thank you for asking. You also probably have it on there.
Not for
Yeah, I fully agree.
he dumped.
In fact, I have mine.
Well, apparently it's like half.
Now that I don't have to shave something,
It's like, dude, it was, he's so good, $8 for food. Yeah. It was $13 for food. Yeah. He said it was $13 more than
I don't know.
I tried to charge me 15 for the 15. Dude, I was not on the business side, I was just coming right through.
Zane,
He said it would be.
are you done?
Oh, I thought it was
Oh.
$7.
Did you both get the same answer? Ask anybody else who's done, see if they got the same answer. Oh, I have one, but I'm going to argue. I'm going to evaluate. Is your brain correct?
Near the end of it, my hair was It's true. We're going
It's true.
I was going. I really
You know they used to
would
give
not.
you sleep in it?
Isn't it?
I was so.
Because it's silly. Why would you do that? You got to have fun all weekend.
They got 3 stars because
Oh, you have the potential energy, you have G, and you have H, right? So you can calculate it.
Let's say we place it
You give you the potential energy.
I'm still so soft.
This feels really
No, you get 2
Yeah.
stars.
Because there's other types of potential energy, so the one we're using is gravitational, but like, there's a lot of thing, I pull a lot of energy that's in atoms or bars is outward potential. So there are others.
Energy, gravity.
Yeah, yeah, so, potential energy, mass, gravity, which is a constant. Yeah, always put in your units. Height is in meters, mass is in kilograms. So are you done? Carol, are you done?
So, I did get a little.
Are you? Good then, I appreciate it. But the pressure
Oh, we just need code words.
Because
Yeah.
we're trying to, it's like explaining how she's on the beam, but
Yes, you
kind
can.
of, it's like weird, so we're talking about dogs.
It is weird because you're graphing it and that
Yeah.
looks, yeah, fair,
So-
okay.
So like, I did this, and then I did like the other one. This. Yeah, you're showing your work, right? Show my work, and then online it. Where it's all your.
Oh, I think you're talking about the worksheet. Never mind, yeah, okay.
Yeah, I know.
But on there you're showing your work, right?
Yeah, but you could've just
Right? Good boy. Show your work.
Show work.
Yeah, showing work is the only part that matters.
That's the part.
Even in Chem 11 and Chem 12, I don't actually care too much if you get the wrong answer, as long as you're working this way. Terrible, terrible. Don't make it. Totally. Yeah. However, once you get good, there are shortcut keys for super short
Actually,
and
yeah.
And having taught to students who have recently returned from university, you gotta do a lot of that.
What the hell is it called?
This guy's helmet dead though. I mean, he's definitely dead. Whoa, there's so many dials on this thing.
Stop touching my point and take this. How do you calculate force?
Question,
Yeah, how do you do force?
Is that gravity? Is force
Lisa, what was the mass in question 5? Yeah.
No. Oh.
Well, I was supposed to,
Well, I don't know. 0.98.
So.
Yeah, so because define work is force times resistance, right?
So, yeah, it's gonna be force and distance. Just
Like I could have everything
because what you can do is, you can calculate it as, force times distance.
force is mass times this.
Yes.
And then work is force times this.
So you know, work,
So it's
and then force, you know,
what I say.
it's just how much you pushing it over how much. But which question is this for? 'Cause
Number one, activity C.
Helps, you know, see it.
The bottom part.
And then what's your intestines though?
Or very bottom?
The first thing has to look at your brain.
It's how much
So I can see the question.
Wait, he just did it for us.
No, I swear. Went through it.
Dude, we're on the same question.
Oh, activities, here we go. Wait, so you're looking for
Yes, but how do you find
C1?
activity C?
It's much more to without anything.
So no, work just equals potential. Because it's like, work plus whatever, like if there's much
It's asking how hard it is to lift it up.
I'm just so strong. I just go gym from
So work is equal to mass times distance, right? So
yeah.
force is equal to mass times distance.
Yeah.
And work
I can't calculate it.
work is equal to mass times distance.
Um, yeah, it's gonna be, yeah.
And force is just force is equal to mass
I
times
just
distance.
use the video, so it's kind of like
No, because, yeah. But you don't even need to calculate that because you can just.
Oh, that's it.
you can put it in this because it's just the same as math.
Because Kieran, you can just do calculate it. Because what's happening here is if the ball's here, and then you lift it, and you take this amount of energy, you still have the same amount of energy to drop back in, right? So it's gonna equal the same amount of energy, it's just with whatever direction it's going, it's just gonna be the same amount. So you just, what's the potential one you go from here to here, so that's gonna be the same amount of work. And so it's
times T equals W. This is a work. And this is also the work. So the work is the exact same thing as the potential energy. Easy.
the question right is how much. Because force, the work is going to use potential energy.
Yeah, because we have different. So when you put the ball on the tip of your shelf, it's equal to the potential energy of it is equal to the force that comes to it.
Oh no, you're wrong.
Your sheet is different, Matthew. You had the work equals PE, right? Somewhere on your thing there's written work equals PE.
Oh, I wrote that in.
Oh,
That's because I was writing down, yeah, I wrote that in.
yes,
But yeah, no.
If I get your attention, I'm going to stop you for another moment. I'm going to attempt to show you.
It says
Okay. Why units are important and why they'll help you out later. There is a problem at the very end that a lot of people ask me about, and they go, you have a mass, it's 2 meters high, put it down. You're supposed to calculate that mass. I don't know if that's right. I just grabbed it off someone. And you need to measure the total kinetic energy at the bottom. And you know the acceleration due to gravity. And so the question is, what is the kinetic energy down here when it's dropped up here? And a lot of students are running into the problem of they don't know the velocity when it hits the ground. There's a completely different way that you can solve the problem. You don't need the velocity. And this is one of those, how do you measure a barometer type questions. There's a way I'm expecting you to do it, and hopefully you'll eventually have that realization. But if you use units, you can actually work out any formula you particularly want. You have acceleration. Is acceleration in that formula?
No.
No. But which one of those values would be related to acceleration?
Velocity.
Velocity. Do you know the velocity when it's hitting the ground?
No.
No. But you know that velocity is meters per second. What is acceleration?
Meters per second.
Meters per second squared. How can you get acceleration to be velocity?
Get the square root.
Square n.
If you take the square root, you're going to take the square root of n.
Sorry, square.
Oh, square root.
There is a
That's-
times it by what? Times it by s. So velocity is equal to meters per second squared, acceleration, times seconds. What value is seconds? What are you measuring there? Time.
Wait, what?
That makes sense. If you're going 9.80 meters per second squared, in 1 second you're going 9.80. In 2 seconds, what are you doing? Let's just say it's 10. In 1 second you're doing 10, in 2 seconds you're doing 20. So this makes sense. So you now know, you could just figure out, oh, I just have to multiply that by time. So velocity equals acceleration times time.
How do we find the acceleration?
Oh, it's the force, it's the gravity.
Oh, that's gravity?
It's gravity. So then you know that acceleration is equal to,
9.8.
no, in terms of this formula.
Oh,
Well, what's time then?
time over v,
If you're moving it over here,
or v over t.
V over t. So then you could say, oh, well now I know that E is equal to 1/2 m v over t squared. Now, is this the formula you'd memorize in Physics 11? Maybe. It's close. The only thing, like, there's a lot of things I haven't accounted for. Like, we're starting from 0, but if you started at a particular speed, you'd have to add that in there, so you'd have a plus, an initial or something there. But if you're starting for 0, this will work. And you can get all of these, because if you know the units, you can look at what you have and what you need to start plugging different things in and how long things would go. That will also, you can rearrange that formula to start figuring out things like how long would it take it to drop and other sorts of things. So there is a particular way and a really easy way that I haven't shown you to solve that problem. And I'm hoping you'll do it that way. But if you want to play around with formulas in any physics, you can derive your own formulas just by looking what units have to go together. I want you to start training yourself to put your units in everything, because with the exception of biology, because their units are the names of animals and parts and organs and organelles. Physics and chemistry, your units really matter. When you get into biology, your units matter too, but you'll probably be more likely doing statistics. That's exciting. If you don't finish that entire worksheet from last day, the one dropping, do grab the printed one before you go so you can practice. How many are either finished or close to finishing? Excellent. I'll just come around and hand it out. Oh, right, because you forgot. Are these chairs comfortable enough for me?
Maybe it's
Because I could go and steal chairs from somewhere else.
Yeah.
There you go.
If work is equal to PE.
Enjoy.
Assuming that
Is anybody here in Jonathan's house?
right?
Who's in Ellis? Who's in Ellis house?
Say 10 joules.
I'm barely in Ellis.
What do you mean you're barely in Ellis?
I only go there between lunch and hours.
Are you a day student?
Yeah.
W.
How dare you not bond with your house?
Work equals PE. Assuming it's going straight up.
Oh, the like 5 multiple choice? Yeah, they showed me the answers.
Wait,
And there's 5 questions underneath the gizmo. After you're in the worksheet and you're used to the calculations, it is intended you go in and quickly answer those, and so that I can check them. Did you get one of these? Yes, you did. Do you have one of these?
No, I remember saying.
If I gave you one for Jonathan,
Wait,
could you give
we
it
just put second student.
Per chance.
per chance?
Question is risk.
That
I
would
know,
be
I'll give it to Brandon.
Stuff online.
perfect. That'd be awesome. And wait until you do calculus. You can derive so many things.
Yeah, but here, and work just equals what you do.
So you see, acceleration equals maintenance percent. You do 9.81 equals
2 over second square.
Yeah, that's a yes.
Yeah, but Kieran, it is work equals
Not in progress.
It's just unless it's going, it's going straight up.
Writing seems to
Otherwise you have to remind it, but assuming it's just going straight up.
Unfortunately, that can be always true, but I don't think progress
So
will be.
it's changing.
Okay, so,
Yep.
like, I don't get it, it says that she moves to the left.
Yeah, it's like, it's the change, because it's like if I lift it up.
Position,
Yeah.
meters. Assume the center of the balance beam is the reference point. So, each part of the graph may be used as often as necessary. The center of the balance beam is here. Origin.
Yeah.
A is the starting point.
Because eventually at some point it's like you can let.
And,
Because then it's.
and F is the end, and F is the end of the y.
But then. But.
So, just stand still for 3 seconds.
So it's not hit the ground, right?
Right.
So when the ball is
And,
here, it's
oh,
it's just like a little bit out.
right.
Oh. Okay. That helps.
What they did to you is took a value you're normally used to seeing linearly and put it on 10.
Another ball that hits.
No, go down there.
So it's like, when close to you,
Doesn't matter. Can't bring it down. But if I like go and then pick it up and I'll just go here, and then pick it up, and I can't go back down.
so when I pick this up, I put it down, it's massive. But if I drop it.
The difference between the difference in the potential energy from the 2 meter shelf to the potential energy from the 5 meter.
Ariel and Zoe, did you do the online questions afterwards?
But the difference between the meters, so you just do
Oh,
get
do
the
those
potential
first.
energies at the 2 meter and look at
Plug
what
it in. Didn't we have this conversation last
I
night?
know, but
What is
he's
Adam?
kind of called.
Who is that? Kieran?
Sorry?
Take your plug and rotate it so someone else can use that plug. There.
I think I tried it.
Mine doesn't rotate. I can put it on the top of the
I see.
Yeah, I actually moved it. Yeah.
So I just put in what it.
Oh, you rotated it and put it on the top. How
I got
charged
the
is
hub
yours?
on to do this.
Nice. How charged is yours?
Mine's full.
Oh, there you go. You can use it.
Oh,
Also, one second. Zoe, for you, remember when the Ross building was destroyed?
She wasn't janitor.
Oh.
No one other than
I went through the whole building to provide extension cords for my students. So if you ever need it, you can just come and plug it anywhere in the room, and then take this and bring it there. Because they left stuff behind.
people take the
CD
pouches.
shells?
But I've taken the pouches.
I stole them from Oran.
Fire.
Yeah, totally fire.
Look at the couches of the Ross.
You mean those things?
Those.
Wait, so
That came from Mr. Patel's office.
So you just.
so when this
I
building
just
gets
took
teared
stuff.
down, we can
Those
just take
shelves?
stuff?
Yeah, this building's being torn down. No, it's not.
Uh,
It's not gonna be used. Yeah,
No.
they're not allowed to use it.
You may be
They're not allowed to
standing
tear it down.
right here, maybe the future home of either Privet, Ellis, or Whittle. Because what
That
they,
sucks. We're not gonna be here to see it.
what I suspect that they'll do is they'll tear this down and then build a brand new residence here. Because,
But then we need a new girls' PPU.
no, they'll build a new one, and then they'll move one of the houses into it, tear that down, build a new residence.
That's gonna be pretty complicated and
Yeah.
expensive.
As soon as I
I would just try the other one down.
Your backpack's a bit.
Because Privet, Whittle, and Ellis, I've heard rumors, is that they're getting kind of old and they like to update.
Yeah.
Now, I think like the bones of those buildings are actually fairly strong, but they want to update. The female residences are all newer. They want more
They
modern
should give
stuff.
the new building to Privet. That'd be.
That'd be nice.
Yeah.
The whole new
The
building.
whole thing.
Privet doesn't have it on the spec.
Yeah, you guys gotta like have the amount of house points that Ellis has.
You guys are not ready.
We're in first, aren't we?
What? Last I heard, we were in first.
Yeah.
You know,
We're in,
second.
you guys are.
However, I could be wrong. What do we have?
almost guarantee
No, I
you
thought
won the
Whittle was
government.
second.
Oh, whoever's.
Oh yeah.
I thought Whittle was the
We
second.
cleaned
Oh, are they?
it up.
But who's ever first, it's like by 2 points or something.
Yeah, no, the one home girl there cleaned up for the government.
Oh,
I
I
don't
thought you.
And then all my stuff in the other bit.
Yeah, good job, guys.
No, I was like, for the.
Okay.
artwork one.
Are
They
you,
did an artwork.
Kieran, are you guys done the FET one?
We're done the Google.
The Gizmo? Are you done all the
yeah,
questions?
yeah.
Okay.
We're gonna give one out. Oh, this is too. How do you turn this one in?
You can't. You just do it. It's like
You just trust.
they just trust you.
Trust.
I didn't know. The 2 kilogram block.
You're such a DB.
2 kilogram block. So, I fixed it. So, jewels, right? So,
Wait, it's just that. There's 2 times 3.
how did that money win?
Oh.
Forgot about gravity.
Okay, so it's 58.8. No, because Kieran, it's not going to be any of these because they're way too small. This one's the closest to 6 you
You
can
guess
guess
it.
Ariel,
Yes.
you have signed yourself up for my class twice.
Oh.
I did the same.
What class?
Oh, I did the same.
I forgot.
Because I forgot my
Yeah, I
password.
Oh, same.
What? I just used the same.
I forgot my account name and
I
password.
made like a really random.
Now that I'm looking through, quite a lot of you have
Like, I
signed
remember my
into it.
password, but I
But-
just forgot the account
It's
name.
like, it was like 2364.
Yeah.
Okay.
He said not to put my normal password. So I didn't.
I feel like
You said not to put my number.
Okay.